Hi guys, hope you're all keeping well. Just a quick video here just to kind of highlight some of the things that we went through today. I will put the PowerPoint of this up as well, just to make sure that anyone that did miss out on the live lesson is able to catch up on the work that we've missed. So today we looked at half-life. So our learning intention for today was to explore the half-life of radioactive elements. And the success criteria, I can define the term half-life and I can calculate the half-life of a radioactive source. So what is half-life? Well, to begin with, I'm just going to go back to activity. So you remember from previous lessons, the activity of a radioactive element is the number of nuclear decays it undergoes every second. So leading on from that, the half-life of a material is the time it takes for the activity of that radioactive source to drop by half. Okay, so you know that obviously that the radioactive materials, the activity of them, it does drop over time. That's why nuclear materials or nuclear waste from a nuclear power station will be safe after, normally many thousands of years, but it will eventually be safe again, and that's because the radioactivity of it, or the activity of it, drops over time. So how do we calculate the half-life of a radioactive source? Well, the easiest way to show you just by doing a worked example. So here we go. A radioactive source is measured to have an activity of 32,000 becquerels at the start of an experiment. After 5 hours, the activity has dropped to 1,000 becquerels. Calculate the half-life of the radioactive source. So the way I just do this, and this is the easiest way I would argue about to do this, is just to sketch out the life of what's happening. I just start by writing down 32,000 becquerels because that's where the radioactive source starts. I then draw a little arrow, and that represents my first half-life. Okay, so it undergoes one half-life, and if the activity is halved, then the activity is now going to be 16,000 becquerels. Okay, now it's going to half again, so as another half-life, and it will have to get to 8,000. Half again, and it gets to 4,000. Half again, it gets to 2,000. Half again, gets to 1,000. So all I need to do here to find out how many half-lives there's been, first of all, is count the number of arrows. So each arrow is one half-life, so that's 1, 2, 3, 4, 5. Let's just write that in. 1, 2, 3, 4, 5. So 5 half-lives equals, and if we go back to the question, 5 half-lives gives us 5 hours. So 5 half-lives gives us 5 hours. So if we just divide the number, or the time, by the number of half-lives, that's all we need to do. Divide the time by the number of half-lives. So if we've got 5 half-lives in 5 hours, then one half-life will take 1 hour. Dead easy. It is as simple as that. There's nothing hugely complicated in how we do this. That's pretty much how we do it. However, we do need to know how to do it a different way as well. The other way we sometimes see these questions asked is in the form of a graph. So calculating the half-life by using a graph. So imagine you're given a graph like this here and you were asked to calculate the half-life. Well, again, it's very easy. All you need to do is you need to pick 2 points on the graph. So first of all, you start by picking your first point. Now, the data here, it just comes from exactly the same as the data we just used. So actually, you can see here we've got 32,000 is just right on this line here. So I could go with 32,000 and I could go with 16,000 because that's right on the line as well. And I could just use those two values there if I wanted. So what I would do is I would just draw that line down there for 0 and that one down there at 1 for, so that's, this line starts at 32,000, that line is at 16,000, and all I do is I look at the difference between these, so that's 0 to 1, it's just 1 hour. Dead easy, simple as that. I could have picked other values. I could have started with 25 isn't quite on the line there. You could look for other ones that are on the line. If I keep coming down here, you'll see that I get to here, and look, there's one there. That is around about, in fact, it's exactly 8,000. I could continue on down. Half of 8,000 is 4,000. That's on the line as well. So I could do 8,000 at 2, and then 4,000 at 3. Again, I'm just looking at the difference in the time here. So that's just another 1 hour. It's exactly the same. I could also have done, of course, 16,000 to 8,000, and that would still have been 1 hour. So you're going to get exactly the same. every time. You just pick one value on here, and then you look at half of that, and you try and make sure that obviously both of those values are exactly on this line, where this line and where two of these lines intersect. That's what you're looking for. You're looking for where two of these lines are intersecting. You want your half-life curve here to be crossing exactly one of those, or as close as you possibly can to one of those. So I'm going to ask a question now. Sorry, half-life of 1 hour. So question, how long would it take for the activity to drop to 31.25 becquerels? Now, this is just using exactly the same data that we started off with in the last question and what we're given in the graph here. So how do we do that? Well, we answer it exactly as we did before. We just draw out our timeline. So we start with 32,000 becquerels. We half that, we get to 16,000. Half it, we get to 8,000. Half that, we get to 4,000. Half it, we get to 2,000. Half it, we get to 1,000. Half that again, and we get to 500. Half it again, we get to 125. Half it again, we get to 62.5. Half that again, we get to 31.25 becquerels. And all we need to do is just count how many arrows we've got here. So let's count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 arrows, that's 9 half-lives. Now, just to remind you from the last slide, 1 half-life is 1 hour. So if we've got 9 half-lives, then that's just going to be 9 hours. As simple as that. These problems don't need to be particularly complicated, guys. Just remember the set way of kind of going through it. Make sure you lay your working out exactly as I've shown you, and you will get absolutely all the marks that you need to get in these types of questions. Okay, so just to finish off, revisit our success criteria. I can determine the half-life. Hopefully you've got that ticked off now. I can calculate the half-life of a radioactive material. If you're struggling with that, just look back at the video. I will post some problems for you tomorrow to have a go at. Okay, so in the meantime, keep yourself safe, and we'll hopefully get to see each other soon.